So in terms of graph behavior, you can want to analyze where our function is increasing or decreasing. So the idea of increasing, decreasing, it's as we're reading our graph from left to right, it's kind of how we typically read a sentence. So with that, reading left to right is the same thing as like starting at small x values and looking as x increases. So if the outputs are getting larger and larger, the function's increasing there. If the values are getting smaller and smaller, then our function's decreasing. So I have 4 graphs here that I want to talk about, and we'll see these graphs again when we talk about concavity. Like this first graph, so this idea of reading left to right, so reading from small x values to larger, our outputs, if we imagine kind of walking along this function and analyzing our y values, those y values are getting bigger and bigger. So because the outputs are increasing, this function is increasing here. With this one, this graph to the right of it, again, we're reading left to right, so as x is increasing. And again, if we think about what our function's doing as we go along, those outputs are increasing. They're getting bigger and bigger, so this function is also increasing. And these 2 graphs have a different shape to them, and that's coming from concavity, which we'll talk about in that next video. This one here, reading left to right, so as x increases, so as we're moving along our function, this is a case where our outputs are getting smaller and smaller, so our outputs are decreasing, which means this function is decreasing. And then this one here, same idea, as x is increasing. If we look at our function values as we go to the right, they're getting smaller and smaller. So this function is also decreasing. All right, some other terminology, this idea of local maximum and local minimum. This comes through in our graph at a very specific spot. So it's like if we zoom into our graph, what are these largest and smallest values that are occurring? And then absolute maximum, absolute minimum is these kind of overall largest value, smallest value. So let's take a look at that with this graph right here. So this graph, we start with a solid coordinate at -4, 1. And then it decreases to a hole, increases back up, decreases down to a sharp corner at x equals 1, and then increases back up to x equals 3, y equals 5. So, talking about where this function is increasing. So when we answer questions about increasing, decreasing, we're using interval notation, because it'll be over an interval of x values where the function's increasing or decreasing. So let's just kind of go through our graph and reading left to right, starting at this -4, 1. So then our function goes down. So in here we are decreasing. That's just kind of between -4 and -3. And then our function's increasing up to that 1, 3. So, sorry, -1, 3. So then we have this kind of section that is increasing. And then our function starts decreasing down to +1, -5. So at +1, so between -1 and +1, our function is decreasing. And then it switches to increasing all the way until we reach that 3, 5 coordinate. So from +1 to +3, increasing. So this is just the idea of if we're like walking along our function, are you going downward or upward, or downhill or uphill, that kind of idea. So how I kind of put that onto the graph, we can now see these sections of increasing and decreasing. And these kind of cutoff points, it's at -4, -3, -1, +1, and +3. So those are going to be the endpoints for my intervals. So with increasing, I can see we're increasing from -3 to -1. So that's going to be one of my intervals. So we're going to have -3 to -1. I'm going to leave the brackets or the parentheses off for a second because we'll come back to that. And then our function was increasing again from 1 to 3. So I'm going to use my union symbol and 1 to 3. Now, increasing and decreasing, the punchline is you're always going to be using parentheses. So again, we use parentheses when we don't want to include the end values. And then we use the brackets when we do include the end values. So let's take a look at this -3 to -1. So first of all, -3 isn't even defined on our function. It's an open circle. So that alone would tell us to not include that point because it's not even defined. But let's take a look at -1. So that coordinate -1, 3. So this is a local maximum because if I zoomed in right there, it's this value that's larger. Sorry, it takes a while for my computer to catch up. Okay. We have this value that's larger than any others around it. So this right here would be a local maximum. So just in that one little spot, it's a maximum value that's occurring. Notice it wouldn't be the absolute maximum because we do reach this coordinate at 3, 5, which has the largest output overall on the graph. But in terms of locally, just that one spot. So when we're here, at this point, 1, 3, if we think about at that coordinate, are we increasing or decreasing? The answer is neither. So if you think about throwing a ball into the air, so if you throw a ball into the air, it goes up and up and up and up and up, and then it reaches this maximum height and it stops for a second. Split second, it's not increasing, it's not decreasing, and then it starts falling back down. So this peak that's occurring here, it's neither increasing nor decreasing there. So even though our point's defined, in terms of describing increasing and decreasing intervals, we don't want to include those points because neither's occurring. So with that, with our intervals, we're going to be using parentheses because we won't be including those endpoints. If they're undefined, if it's this local maximum where it's technically doing neither at that point. Same thing for this interval 1, 3 at x equals 1, we're at this coordinate, and that's a sharp turn between decreasing and increasing. So at that point, neither is happening. This would also be considered this would be a local minimum, because if I zoomed in, it's the smallest value. It is also the absolute minimum because it's the smallest value overall on the graph. Smallest meaning the y values, but we wouldn't want to include that. And then at x equals 3, which is the end of our graph, we can't, it's increasing to the left of it, but we don't know the behavior to the right of it because our function stopped. So we just say at this point, it's neither increasing or decreasing. We don't have information to the right of it. So increasing and decreasing, always use just parentheses. You won't be using brackets at all. Okay, let's do the same thing with decreasing. So our intervals where our function is decreasing, we started at -4, and then we're decreasing until -3. And then it picks up again at -1 and continues decreasing to +1. And we're just using parentheses because we don't want to include those endpoints. All right, so that's how we describe increasing and decreasing with a function. Oh, just to kind of finish up with local and absolute minimum. So we have a local maximum here, local minimum and absolute minimum at that 1, -5. This coordinate 3, +5, this would be the absolute maximum because it has the largest y value, and then that would do it. Typically endpoints we don't describe as local minimum or maximums because we can see what's happening on the right-hand side, but we don't have information to the left of it. So with that, it's just an endpoint. And this spot where we're undefined at -3, -1, even though it's dipping down to this value, if it was defined, that would be a local minimum, but because the circle's open and we're not including that coordinate, it isn't anything.